Okay, this video will be much shorter than the first, now that you kind of get the idea with what we're doing. Moving into operations, now we're going to multiply and divide the expressions. So just a basic, well, before I get started on this, let's skip listing excluded values for right now so that we can focus on just the skill itself, just applying the operation. So I wanted to state that at the beginning. Multiplying fractions, the basic rule for fraction multiplication is just multiply straight across. And then simplify whatever, simplify the ratio, of course, using the skill from the previous video. So a basic example here, 3 times 5 is 15, 7 times 2 is 14. So there's your simplified fraction. Stepping it up now, introducing some variables and having things get a little bit more complicated. I always like to simplify each individual ratio. The only rule would be as long as common factors are on opposite sides of the fraction bar, or you can choose to multiply everything together and then clean it up as you wish. I'm going to go ahead and write it as one big fraction. And let's see, I've got x squared and y squared. And then the denominator, I've got 33 and 5, and I've got an x and I've got a y. I've just arranged it so that I can see the things that are going to divide out. Looking at this, I see that 11 and 33 share 11. So here's my simplified. This is what's going to be left over. 3 is going to remain. 25 and 5 share the 5. So I will have a 5 left over on top. Looking at the x's, x squared over x, using exponent properties, 2 x's on top, 1 left in the bottom. I'm going to have 1 left over on top. That would be x squared minus 1. And then in the y's, y squared. So this is going to be y to the 2 minus 1. The 1y that's left over will be in the numerator. So anything that's common divides out top to bottom, and the pieces, factors that are left come together to create their own fraction. Let's look at the next example. So here, giving you some GCF factoring. I'm going to write it as 1, but as I do, I'm going to pull out some pieces. I've got 5 and 15 right here, just multiplying straight across. And let's see, 2, I'm going to have x minus 5 if I reverse distribute out a 2 right here. And in this denominator, if I reverse distribute out a 3, that leaves me with an x minus 5. I'm just arranging this so that I can see all of the common pieces that I would divide out. If I had to list excluded values, x would not be allowed to equal positive 5 because of this x minus 5 in the denominator right here. That's the expression that would create division by 0. Moving on, let's simplify. So 5 and 15, that's going to leave behind a 3. 2 and 3 share nothing. And then the binomial x minus 5 will divide out. And then the pieces that are going to remain, I have a 2 on top and 3 times 3 in the denominator, leaving me with 2 over 9. And I'm just trying to show you all of the pieces in a way that's easy for you to visualize so that you know what your end goal is and how to get there. Moving on to division. If you can multiply, you can divide. Division rule for fractions. Take the second fraction and turn this into a multiplication by taking that second fraction and flipping it or writing it as the reciprocal. So this is really A over B times C over D. So the second fraction, write it as its reciprocal and change the operation to a multiplication. And then it's exactly like the skill from above, multiplying straight across, A, C, B, D in the denominator. Simple example here, I've got 5 over 12. I'll turn this into a multiplication problem, and I will flip 36 and 20. You can simplify first before you divide, so I'll do that on this one. I'll simplify first. I see that 5 and 20 have a common factor of 5. When I divide that leaves me with 4. And 12 and 36 share 12. So what remains is 3 on top and 4 in the denominator. So devise a way that always works for you, please, when you're doing this. Okay, let's introduce some variables in. Let's see, I'm just going to rewrite this, and I'm going to keep it the way that it is. Got 15. I could simplify first, but I'll just go ahead and just turn this into a multiplication and then simplify it once I get it rewritten. Okay, the first thing I notice is 14 and 28, leaving behind a 2, and then 15 and 45, leaving behind a 3. I'm going to set myself up with a new ratio. I'm going to have 3 on top and 2 in the denominator. I don't think I made a mistake. And now let's deal with the variables. So I've got 3 x's on top. When I bring together x to the first and x squared, 1 y, and then in the denominator, I have 3 x's and 1 y. So just bringing all that together within the same fraction, and then hopefully it's easy for you to see that they're going to divide out, and then the 2 y's will divide out, and the only thing left standing would be the 3 over the 2. Moving to the next example, getting into polynomials now, a little bit of quadratic factoring. The first fraction contains 2 patterns, and the second fraction, I'm just trying to make this simple for you all to see what's happening. The second fraction, this is the pattern where you have the same binomial times itself, and this is just a GCF factor. So here we go. So here, these are the 2 patterns, difference of squares. So when I recopy this, I'm going to factor it as I recopy. This is the pattern where you've got 2 perfect squares, the conjugate pattern. One operation is addition, one is subtraction. Looking at the denominator, it's the same type of pattern, x plus 5, x minus 5. Anytime you can factor efficiently and quickly, it's going to save you a lot of time in this unit. Taking the second ratio and flipping it, the GCF here is 10. So if I reverse distribute out a 10, I've got an x plus 5 left over. And in the numerator, if you don't see the pattern with this, I'm looking for factors of positive 4 that add to negative 4. That's going to be negative 2 and negative 2. And to go through that process, x squared minus 2x plus 4. Introduce your grouping symbols in. The GCF in the first pairing is x. And then the second pairing, I take out a negative 2. And let's see, did I copy that wrong? Let's see, minus, minus, wait. That's going to change that sign. Wait, hold on, I made a mistake. That's going to change this sign. And let me start this over. Okay, here we go. All right, so recopying this, I'm going to use, let's see, okay, this is going to be x squared minus 2x plus 4. When I introduce my grouping symbols in, the first pairing, they share the x, leaving me with x minus 2. In the second group, I also need to create x minus 2, so I will reverse distribute out a negative 2, leaving me with x minus 2, and then you can see that the 2 matching binomials are x minus 2, x minus 2. So it's the pattern where you have the same binomial times itself. That's another pattern with this. Moving back to my problem though, this now becomes the denominator when I did the flip, and this is now going to be x minus 2 times x minus 2. If you had to list excluded values, you would take each denominator factor, set them equal to 0. X would not be allowed to equal positive or negative 5 or positive 2, just to kind of keep that skill fresh in your mind. All right, now it's time to divide out. So when you have something that's this complicated, you need to factor all 4 pieces, all the numerators, all the denominators. Normally you would list excluded values, and then once you get that set up, then you're looking for common factors top to bottom to divide out. And let's see, I've got x plus 5, x plus 5, x minus 2, x minus 2. And anything that's left standing, the only rule is they have to be on opposite sides of the fraction bar. They don't have to be from the same fraction, but they do have to be on opposite sides of the fraction bars. Then anything that remains, just bring that together and create your simplified expression. You can leave it in factored form, or you can multiply it out. It doesn't matter, both are correct. And here I've given you some problems to test your understanding. If you want to stop the video and try them and then turn it, start the video again to see what your answers are. If you just want to watch what I'm doing, it doesn't matter. So the first expression can't be simplified. I'm just going to copy it. Notice that they're connected by multiplication, so I don't need to worry about a reciprocal. And let's see, this numerator, I need 2 numbers that multiply to negative 3 and add to positive 2. So it's going to be plus 3 and minus 1. And then the denominator, I need 2 numbers that multiply to -2 and add to -1. So that's going to be -2 and +1. And then even though the first fraction, even though the factors weren't presented with grouping symbols, the fraction bar is its own grouping symbol. So you would assume that those pink parentheses were there. And now to simplify this, I guess my intention was to have some of the other things fall out. So I see what I did when I made the problem up. The only thing that's going to divide out is x minus 2. If I would have chosen to do, the better problem would have been if I would have made that a +3, then you would have been able to subtract, you would have been able to divide that out. That was probably my intention when I made the problem, but I didn't catch that. So with this, that's the only thing that divides out. And then your simplified expression would just be x plus 3 times x minus 1 over x minus 3 times x plus 1. And sometimes that's what happens. Things don't all fall out, but that wasn't my intention when I made the problem up. Anyway, here we go. Let's go to the next one. All right, so GCF of 3. And then that denominator is a little pattern to make your factoring faster and easier. +4 and -4, 16 is a perfect square. This is a division problem. Turn it into a multiplication. And since the lead coefficient is +1, hopefully you can mental math your way through this. This is now what I'm looking at. This is my new numerator. I need two numbers that multiply to -8 and add to -2. So that's going to be -4 and +2. And then I'll color code this one. This is now my new denominator right here. I'll give him green grouping symbols. And I need two numbers that multiply to -8 and add to +2. So that's just going to be +4 and -2. Now, analyzing for common factors top to bottom, that's the only rule. They just have to be on opposite sides of the fraction bar. And once again, did I do the same thing? I made up a problem. And no, here we go. No, okay, here we go. So -4, -4, -2, -2. And no, that's it. Then the factors that are left over that did not divide out, they come together to create their own little fraction. And I'm just going to write x plus 4 once and square it. You could write it twice if you want to, but I think that is enough for this video. I want you all to stop and practice multiply divide.